All right, let's dive into one of the most mysterious, powerful, and frankly, explosive substances in the entire universe: antimatter. So, I want you to just imagine for a second, what if there was a world out there that was a perfect mirror image of our own, but made completely out of antimatter? What would it actually be like to go there? Well, to put it mildly, you wouldn't want to touch anything. Because when matter and antimatter meet, it's not just some chemical reaction, it is total, absolute annihilation. And just to give you an idea of the scale we're talking about here, if a regular 175-pound person were to shake hands with their antimatter twin, the explosion would unleash the energy of 150,000 nuclear bombs. Yeah, that's not a handshake, that's a planetary-level apocalypse. Okay, so before we pack our bags for this anti-world, we really need to get our heads around what antimatter is. And it all boils down to this really beautiful but dangerous symmetry baked into the fabric of the universe. Think of it this way. For every single particle of matter that makes up you and me and everything we see, there's an identical twin, an antiparticle. And it's a perfect match in every way, except for one critical thing. Its electrical charge is flipped. Our positive protons, they have negative antiprotons. And our negative electrons, they have positive twins called positrons. It's a perfect mirror image. You know, it's kind of like a simple math problem. When you ask for the square root of 4, you actually get two answers, right? You get positive 2 and negative 2. Well, in a very similar way, when pure energy transforms into mass, it can pop out both a matter particle and its antimatter twin. They're two sides of the very same coin. But this whole perfect symmetry thing, it leads us to one of the biggest mysteries in all of physics. If the Big Bang was supposed to create equal amounts of both matter and antimatter, then where is it all? Where did our other half go? Now, to even begin to get this mystery, you have to understand this one crucial word: annihilation. This is what happens when a particle meets its antiparticle twin. They don't just break apart, they completely vanish, converting their entire mass back into a flash of pure energy. It's really as simple as +2 meets -2, they cancel each other out, and poof, they're gone, leaving nothing but energy behind. It is the universe's ultimate reset button. And that brings us to the huge universe-sized paradox. I mean, if the early universe was this hot, chaotic soup of equal parts matter and antimatter, all bumping into each other, why is there anything left? Why didn't the whole show just cancel itself out moments after it began, leaving behind an empty cosmos filled with light? So how in the world do you solve a mystery like that? Well, physicists have been on the case for decades, and they've come up with a couple of really fascinating, though very different theories that could explain why our matter-filled universe is the one that survived. So, theory number 1 is that the universe kind of cheated, just a little bit. The idea goes like this. The Big Bang is creating equal pairs of matter and antimatter, just like we thought. But at the same time, other particles, like the famous Higgs boson, are also decaying. And it turns out the Higgs might have had a slight preference. When it decayed, it created just a tiny, tiny fraction more matter than antimatter. So after all the fireworks, after all the annihilation, that tiny surplus was all that was left over. And that little cosmic crumb, well, that became every star, every galaxy, and everything we see today. Okay, if you thought that was wild, get ready for theory number 2. This one suggests the antimatter never disappeared at all. It just went the other way. Picture the Big Bang as the number 0 on a timeline. Our universe, made of matter, expanded forward in time, +1 billion years, +2, and so on. This theory proposes that an entire anti-universe made of antimatter could have expanded backward in time from that same starting point, -1 billion years, -2, a perfect mirror universe, forever separated from our own. It's a pretty mind-bending idea. All right, enough with the heavy physics for a second. Let's have some fun with this. Whether it all got destroyed or it's hiding in another timeline, let's just pretend for a moment that there is an antimatter planet out there, and we're brave enough to try and visit it. Seriously, how would you even begin to explore a place where a single breath of air, a single drop of rain, a single touch would mean you instantly cease to exist? And the crazy part is, the survival guide for this isn't total sci-fi. It's based on real principles that scientists at places like CERN actually use to handle antimatter. First, you need an insanely powerful magnetic shield around you at all times, like a force field, to physically push away any antimatter particles. Second, for power, you'd actually use the planet against itself, carefully bringing a little bit of your own matter to react with the local antimatter to generate huge amounts of energy. And third, the most important rule of all, don't touch anything, ever. And I really want to be crystal clear about the stakes here. You could see a beautiful, clear stream of anti-water. It would look exactly like our water. But the second it touched your lips, the antihydrogen and antioxygen would collide with the regular H2O in your body and, well, let's just say you wouldn't feel thirsty anymore. So we've been talking about antimatter like it's this crazy, exotic stuff from the other side of the universe. But here's the twist in the story. It's not just out there. It's actually right here, and it's even inside you. But first, just to get a sense of how unbelievably valuable this stuff is, because it's so difficult to make and even harder to store, scientists have estimated that a single gram of antimatter would cost about $62.5 trillion to produce. That makes it, by an astronomical margin, the most expensive substance on planet Earth. So if it's that valuable and that rare, where is it? I mean, we can't pop over to the anti-universe to grab some, so is it all just locked away in high-tech labs in Switzerland? Okay, are you ready for this? The amazing, kind of mind-blowing part is that antimatter is created naturally all the time in really small amounts. Take bananas. They contain an isotope called potassium-40, and as it decays, it naturally releases positrons, particles of antimatter. And since your own body also contains potassium, that means you, yes, you, are a tiny walking antimatter factory. You produce about 180 positrons every single hour. They just annihilate with a nearby electron almost instantly, so you never notice. And all of this kind of leads to this really profound philosophical idea. You know, we live in a universe that is completely, totally dominated by matter. So all of our science, all of our laws of physics have been built based on the rules of this one substance we know. Which leaves us with this one last big question to chew on. Is our entire understanding of reality fundamentally biased just because we've only ever seen half of the picture? Could there be an entire anti-reality out there operating under a perfect set of mirror image laws completely invisible to us, just hiding in plain sight?